Hello, hello. Welcome to another session on this YouTube channel focused on automation in CICD. Today we're going to iterate from where we were last time, where we talked with Adriel around the OpenTelemetry CICD special interest group within the CNCF. And we're going to bring the GitHub receiver that Adriel has built to action. And I'm joined again by Raphael. Raphael, welcome back.
Hello, Johannes. Thank you for having me again on your show.
Feels like you're being part of this channel for too many times, so we need to make sure that we somehow credit you for that. But to make it less boring, I've invited another friend of us, right, back to the show. You know David?
Yes.
He's the inventor of builders cards, and he lives very close by to you, if I remember correctly.
Yes, that's correct.
And there's a special card that he gave me just at the AWS Summit in Hamburg. I think I had it before, but it's a card that features himself, so it's pretty funny. And I thought I'm going to invite him to join us today. Cool. Raphael, I already kind of spoiled what we're going to talk about. Let's have a look on how that actually works from an architecture perspective. So what the hell are we going to look at today?
Yeah, so our goal is today to get better observability or insights into our GitHub repositories. Especially we can get some metrics out of it, but also get a trace view of the actual workflow runs in the GitHub Actions. We had that with the GitHub Action last time or somewhere else. And now we are looking at how we can get this data into our solution without having each team deploy a specific workflow. For that, there is a GitHub receiver for the OpenTelemetry collector. So the OpenTelemetry collector is an open source agent or tool that can receive or crawl data from different sources and then convert it into a standardized format called the OpenTelemetry format for metrics, logs, and traces, and export it in a standardized way to a third-party solution, to your own database system, whatever you will want to store this kind of information from the standard format. And there's one for GitHub as well. So what we will do is we will set up an OpenTelemetry collector with this specific GitHub receiver setup.
But this means, so sorry, Raphael, this means that this architecture is a little bit more complex than the thing that you and I looked at, I think that the last before video, right? Where we just added the post-processing step in the GitHub action, right? With this architecture, we need a collector running somewhere for OpenTelemetry. That means we need some pieces of infrastructure that actually serve as a processor, as an endpoint of the OTel data. Is that correct?
That's correct so far. If you want to set up your own, maybe some of the providers will take the heavy lifting for you and provide this receiver somewhere in their backend. But if you want to get started quickly, you definitely have to run a collector, or it is a small container you can deploy to your infrastructure and then call the GitHub APIs.
Okay, cool. And that's what we're going to look at today, right? So the main change over here is in the diagram is the webhook part down there on the left-hand side, right? We are directly receiving the webhooks from GitHub to the OTel collector, and that will then give us a real-time information into what is actually running in the CICD pipeline. And I think it also gives us traces, if I read the documentation correctly, right?
That's right. So whenever there's something happening in the GitHub Actions, a webhook will be called like job started, job ended, and step. And then you get all this information delivered to this endpoint, and then you can extract a span or a trace view out of these webhook events that you are getting in real time instead of to post-processed executed workflow file.
Perfect. Cool. Enough preparation. Let's dive into technical details. How the hell did you prepare this?
So, of course, we always start with the documentation part because we are good developers. So we read the documentation. And luckily, there is a documentation for the GitHub receiver. So as mentioned, it is one configuration file that is delivered through the OpenTelemetry contrib distribution. So there are different kind of distributions for the OpenTelemetry collector, but if you use the OpenTelemetry collector contrib, then the GitHub receiver is part of this distribution. So you can directly get started with setting up the receiver by looking at the documentation. So what you need is, if you use the scraper feature, you need to set up this extension with a GitHub access token to be able to crawl the data from the GitHub API. But we were looking at the traces view, so we want to set up the webhook instrumentation. So we define a receiver, a GitHub OpenTelemetry collector receiver. This is the actual implementation, the GitHub receiver, and then we have a configuration. In this case, we want to configure the webhook for some exposed endpoint, for some port, for some path that is actually receiving the webhook events. Then we can have a health check if you deploy to a cluster to make sure this receiver is actually working. You should secure your endpoint with a secret, so not everyone can send you some data. And of course, if it's publicly available, definitely make sure that we might have some buff in front of the endpoint. For our demo purposes, we will skip the security part for now. So this is definitely only a POC, not a production-ready setup. So how do we get started? So let's look at So the collector file is basically setting up some configurations like the extension for the authentication for the scraper. And then we define our receivers. In this case, the default ones are the OTLP receivers, but we are focusing on the GitHub ones today. So we say the scraper should run 1 second after the collector starts, and then every 60 seconds to scrape the API. This is a value that you need to tweak depending on how many repositories you are calling, because you will easily run into rate limits in GitHub otherwise. In this case, I'm scraping my own repository, the CICD observability one that we used in other examples as well. Use our authentication, and the second part is our webhook. So we are exposing the webhook on any network device on our container. With port 8080, we receive all the events on /events and the health check here. So if we now start up our doc, so this is now all packaged together.
Can we go back to the diagram for a second, right? Because this configuration that we just saw at the end is just the configuration for the left-hand part, right? So for all of the receiver part is the configuration that we just saw, right? So everything that is in that receiver box. And I think there is the other part where we export the data from the collector to a backend, right? I think that's what we also need to look at. In this case, in this example, I think this is, again, the wrong one. We are using -0 as a backend again, right?
Yeah, so we are exporting to debug, so console out, and we are exporting it to a third-party solution. It could be your own endpoint or whatever solution you have in place. And then we are defining our pipelines. So we say for our traces, we can receive OpenTelemetry traces and GitHub traces. Then we don't have a processor defined and want to export it to the debug, so console out, and the OpenTelemetry endpoint. So this is the charm of having the OpenTelemetry collector. You can define pipelines where you can route your traffic to different endpoints and transform it on the way. We do the same one for metrics. So again, the GitHub receiver is offering us metrics as a receiving part, and we are exporting it to our backend.
Cool, thank you. That means that with that we have all of the configuration described, and this is now an MVP for getting us started. So we just need to run the container somewhere now, right?
Yeah.
Which I think
I will run it locally. I prefer the Docker Compose file for that, and I can simply run up with Docker Compose, which start up the OpenTelemetry collector. So we already see some logs. It seems to work fine. Starting GitHub receiver server with endpoint /events. And the second thing I did is now I need to make it available to the public internet. So GitHub actually can send us out the webhook events. I used for that the service ngrok, which is like a reverse proxy whatever thing that gives you an HTTPS URL, which is in the end pointing to your local host application, in this case the 8080 port. And so with this URL, I can now go over to the GitHub repository and set up our webhooks. So if you go to settings and then you have the configurations for webhooks, you can add a new webhook by specifying the URL, which is now our publicly exposed ngrok URL with the path for events. Then I decided content type application JSON. You can configure the secret depending on your configuration, and then you can either send me anything or a subset of individual events. I think depending on the documentation, its workflow jobs and workflow runs should be enough to get all the tracing information out of the GitHub events. So I did already set up this one for my local setup. So now all the events should come in here as we see in the debug tool. So let's start another run of our workflow. So go back to our repository, open the GitHub Actions tab, start a workflow run.
So the webhook now means that every event that is triggered by the workflow will directly reach the HTTPS endpoint that we defined. We will now see that in the debug overview. This is what Raphael is showing right now. And we will then also see that later flowing through the debug log. Okay, cool.
So you see there's a lot of information delivered to our endpoint. Some of the events are accepted, some of them are ignored by the receiver. And if we go back to the receiver itself, since we have enabled the debug view, we see already there is some traffic happening in our collector. So we are generating different kind of spans related to a trace. And this is a quite a simplification of visualizing. So let me jump over to a visualization tool like -0 or any other backend. It could be also like Jaeger or whatever you have in place. And I think even it could be AWS itself, so they also expose OpenTelemetry endpoints to send data there, to probably see it in X-ray or somewhere else. And if I now look, for example, this trace, let me jump to the root of the trace. This was our workflow run that we triggered. And if I look at the trace view, of course, there was an error. Now you see, again, the same view we had for the GitHub Actions view, but you can easily drill down all the steps that happened, how long they took, and you see there's the release flow is red marked, so there must be an error somewhere. So if you scroll down, okay, it was the quality check, the run linting job. And now you can use your observability tool to narrow down. You can build alerts on it. You can see anomalies. So for example, we track the duration of the span. So you can see, is this taking longer than expected? What is our overall workflow run? You can build a dashboard, a metric, an alert if this time is increasing over time, and monitor your CICD best practices.
But this time I would also be able to see this trace kind of live. So if we, I don't know, we could now potentially simulate a long-running workflow, right, by adding a delay somewhere, right? And then we would be able to see parts of the trace without the workflow being finished, right?
I can try to simulate it. I have something part of this thing. I'm not sure if it's working and it's easy to see, but if we now see the workflow run, it is started, so we should already have some kind of data in here. So we get events definitely already. I'm not sure when the trace is generated. Let me check. Maybe the root span is not here already, but I think that run looks good. That is, do I see the run ID? Yeah, but you see that the data is coming in as we talk. It's maybe the visualization because the root span is not available yet.
And the workflow is not yet finished, right?
Yeah. Yeah, the root span is missing, so you get a partial part of this span, of the trace actually. So this would be immediately triggering all the alerts, no matter if the workflow has stopped or not.
Cool.
So if
Because
you have
this also gives us
if you have a workflow that runs multiple hours but already failed after 10 minutes in some kind of steps, but for whatever reason continues to running, you already get your alerts based on your alerting rules immediately when the events come in.
Yeah, and it also gives us the possibility to see stuck workflows, right? Sometimes you have a front-end test that waits forever to find a specific event or something like that, right? Or a specific UI component, right? And you would be able to see those CI/CD pipelines running up here as well, right? And you could also trigger alerts on that as well.
It could be a little bit complicated because this kind of step would still run and would not report back that it's taking longer, because it's reporting back the steps results after the step has been
but it would report that the step started, right? And I would be able to see that. I think I should be able to see that somehow, right? Okay, cool. We also get some metrics that are being scrapped from GitHub as well, right?
Yes.
And we also get the metrics to get matching to the traces that we just looked at, right? How do you think this? What kind of metrics do we get, and how do you think this will help us?
So besides the metrics that are extracted from the spans itself, so you can always query the spans and see the distribution, how long each step took, and if there is a big variance, that would be an analysis task for the scenario you talked about previously. You want to see which task has the biggest variance in execution time, then you can retrospective query your data and all these spans and do an analysis on that. And if you want to look more on metrics based on the repository, then the GitHub receiver also emits data like how many changes have happened in the repository. Probably these are commits. Then I found this quite interesting, time to merge. So it will keep track of how long is a branch open before it gets merged. So you can generate cycle times for pull requests or something like that. You can see the contributor count. That might be in an enterprise not that relevant, but if you apply it to an open source project and want to monitor your open source project, that might be an interesting metric to identify, to see if it's an upcoming the trend of the contributors, because it's also tracking the over time different. It's not like we have 150 contributors. No matter what time, you can see how when it's growing and when it's not growing. It's more fine granular. And if I look back a little bit more, let's take that one. There are more attributes like how many lines have been changed, how many revisions, how many repositories are you tracking. These are all metrics that might make sense in an organizational level to keep track of your GitHub usage. In the same tool, that's the big thing. In the end, you are putting all the same tools together. It's not like, I think GitHub was opposing this data as well inside their tool, but let's say you have GitHub, maybe you have also GitLab, maybe you have also other tools in place, and now you can use the same tool in the end, your own observability provider tool, maybe their Zero or anything else, or your Grafana or whatever, and give the same analysis throughout your different systems. That I think it's the biggest benefit of having this centralized view on the data.
And this is important in bigger organizations, right? And also with going back to the semantic conventions that we talked about in the last video with Adriel, this also gives us the possibility to compare different teams that are using different CI/CD tools at the same observability dashboarding kind of tool, right? Which then brings us to being able to create dashboards that showcase things like DORA metrics, right? And kind of important information that are being treated in the industry as standard terms that you need to understand.
Yeah, when I quickly reference here, so there's also a GitLab receiver. I'm not sure the current state it is in and how good it is, but in the end, it has the idea, if you have GitLab and GitHub in your organization, you can pull in the data and build the same dashboard, the same analysis between those systems, and don't have so for your analysis, it's now the technical implementation. If it's GitLab, GitHub doesn't matter. You want to see how many commits your developers do or how fast are they deploying to prod, and don't care about the underlying system. And with the semantic conventions, you write the same query and say, okay, give me the metric name we just identified, the time to merge, no matter the repository. Or you can split it then afterwards because it's dimension, but you don't care about where the data is coming from. And yeah, you also mentioned the DORA metrics. So there is from Grafana a nice overview what you can do with CICD observability data. Especially for the DORA metrics that they are interesting. You can build dashboards, see your workflow counts, your lead times, and make analysis to comply to these metrics and these requirements in your environment.
Cool. Thank you. This is a great forward-looking thought, and I think with that we covered everything we were planning to cover today, Raphael. Let's summarize. What did we learn?
So what we did is we set up observability for our GitHub repository or GitHub organization in a centralized way. We use the OpenTelemetry collector with this GitHub receiver to pull in metrics about the repositories and get traces from the webhook events that are emitted by the GitHub organization. With this information, now we are in a situation where we can analyze our existing CICD best practices. We can build dashboards, but we can also build alerting and analyze further where we wanted to improve based on the data we are emitting to our centralized tools. And with the power of semantic conventions, when we onboard other CICD providers, for example, and then we can still correlate the data and query it with the same language without having to do specific queries for the different platforms. And all that was possible by just configuring an OpenTelemetry collector receiver. And if you're in the OpenTelemetry space, you probably also already have a collector running, so it should be an easy extension for you. And maybe some of your observability providers have that running for you, so you can easily integrate with them.
Yes, and one addition to that is that if you want to set this up for hundreds of repositories within your organization, the best way to do that would be using a GitHub app, right? That you can then install directly in an organization. That would then replace the setup of the webhooks that we have seen today, which we did on a by repository basis. Cool. Raphael, any last words?
No, I'm hoping to see you again soon. And I think we have a lot more topics for the future to cover.
Thank you so much for watching. I hope you enjoyed. Let us know what you think. And if you're struggling with setting things up the way that we did that, please let us know so we can try to help you. Bye-bye.
Bye.